So let's watch closely and see how we do this. Again, I'm going to be inputting this equation solved for the variable here, which is the elevation angle. So the very first thing I do is hit equal sign, and on the other side of the equal sign, I'm going to type in ASIN. That is the arc sign of that particular variable, because you see I have the sign here. I want to move that over to the other side. So in order to do that, I have to hit A sign. I'm going to go ahead and open and close my parentheses. Now before I do anything else, I want my final answer to be in degrees. So before I put anything else in, I'm going to go ahead and multiply this times 180 and divide it by pi. That tells me that when I get everything said and done here, it will revert back to degrees. Now let's get on the inside and start doing the dirty work here. Okay, first I can see that I have sine of the latitude times the sine of the declination angle. So I'm going to type in sine of the latitude, which is 0. I must remember to multiply that by my conversion factor. Close up that parenthesis. Put in another multiplication sign. Type in the word sine. Open and close. Go back inside your parentheses here. We're now going to do the sine of the delta sub s, and I'm going to multiply that by my conversion factor. All right, we've got the first part of this equation taken care of. The next thing I'm going to do is I'm going to get back on the outside of that parenthesis I just opened. I'm going to hit the minus sign, type in cosine, open and close my parentheses. Get on the inside of those. First thing I have to do is take the cosine of my latitude, so I just clicked on the latitude cell, multiply that by my convert to radians factor, get on the outside of that parenthesis, then I'm going to multiply this by the cosine of the declination angle. So I'm going to come over here and click on that, multiply that by my conversion factor, which is down here, and then finally I'm going to multiply this by the cosine of all the stuff that you see here. And this is where it gets a little tricky. I'm going to go ahead and open and close the larger set of brackets. But the thing you have to remember is, when you look at this, there's going to be a distributive property here. So this part of the cosine will have to be multiplied by my convert to radians factor, and so will this. We'll have to multiply both of them by that factor. So let's take care of the c TUTC divided by TD first. Inside of my parentheses, I'm going to go ahead and open and close the top part of this. I'm going to take c, multiply it by TUTC, which is right here, and that's what's on top. So I can also at this stage go ahead and multiply that by my conversion factor. Now I'm going to get outside of that parenthesis right here, and I'm going to divide all of this by my TD, which is 24 hours. I'm going to come outside of that parenthesis right. Let me check this again. 1, 2, 1, 2. So I've already opened 2. What I need to do is actually add in an extra parenthesis in here so that this will all fit and work right. Now I'm going to come outside of this parenthesis and I'm going to subtract the lambda e, which is the value of our longitude. I can't forget to multiply that by our convert to radians factor. And then finally make sure that I've closed up all my parentheses with one more just like this. Now this equation looks pretty hairy, and hopefully I've put everything in correctly and opened and closed all my parentheses correctly. If I did, we should get an angle of somewhere around 71 or 72 degrees. So let's see if we did everything correctly. Sure enough, we did. 71.37 degrees is the solar elevation angle if you're on the equator on January 29th. So not quite directly above head, but very, very close. Now again, at any time when you're watching this and you're working on this assignment at home, don't forget you can pause it and take a look at that equation as I typed in it to make sure that yours looks exactly the same. Now here's the really cool thing about Excel. Once I've done this calculation one time, I can go over here to the bottom right hand corner of that cell until my plus sign turns into a solid black plus sign, and I can drag it all the way down to do the calculations for the rest of the latitudes. When I do that though, do you see how everything doesn't work? That's because when you drag one cell down to the next, all the variables change by letter and by row number. And we don't want that to happen for just everything. For example, we want our constants to stay constant. And this is how you get that to happen. You see, the only variable we want to change is our latitude. Yet when I go from this cell to the next cell, if you can see very closely up here, you will see that all the variables are changing, and we don't want them to change. So here's the trick, and this is an important trick. Let's go back into this cell. Any cell that we want to stay constant, we're going to wrap the letter of that cell with dollar signs. So the only cell that we're not going to, the only cell that we're not going to wrap in dollar signs are the ones that are called D2. But B19, I want that to stay constant, so I'm going to put a dollar sign on that side of the B and a dollar sign on that side of the B. B7, I want to stay constant, dollar sign, dollar sign. B19, I want to stay constant, dollar sign, dollar sign. D2 is allowed to change, but B19 over here, dollar sign, dollar sign. Same with B7. Again with B19. Now into B3, B5, and B19. Let's finish up with B4, B2, and B19 again. Again, by putting a dollar sign on each side of the cell's letter, I'm locking it into place. And what that does is that only allows the unlocked cells, in this case be this D2 and this D2, to change as we go down column E. So I'm going to go ahead and enter. I'm going to come back over here, turn my plus sign into a solid black plus sign by grabbing the bottom right hand corner of this cell and drag down just like that. Now what you can see is it's calculated the solar elevation angle for these latitudes. What's interesting to see here is that if you were on the Arctic Circle on January 29th of this year, the sun at noon would only get to be 4.9 degrees above the horizon. Everywhere north of there, do you see how the elevation angles are negative? That means that the sun is actually below the horizon. And we know that around January 29th, the North Pole has already been in about 4 months of darkness. So you can really see how this calculation tells you what the sun is doing. So now I've got you started, you have to try to calculate this for June 21st. Before you do that, don't forget to calculate the solar declination angle, and please don't forget to convert to radians. Good luck!